Right, so here we're looking at probability again, but this time it's probability trees. Now, probability trees are a way of displaying the probability that one thing happens after another. So two things happen. Let's talk through an example. Let's have a typical example is having a bag which has got some marbles or something in it. We're going to have 1, 2, 3 blue, and we're going to have 2 purple. Now, what I'm going to do is I'm going to take a ball out of that bag, look at the colour, put it back in the bag, and then pick another one. So let's start with our first pick. It can be either blue or purple. Blue or purple. And the probability that it's blue is 3/5, because there are 3 blue balls out of 5. And the probability that it's purple is 2/5, because there are 2 purple balls out of 5. Don't forget, probabilities, if you're listing every possible outcome of something happening, if I pick a ball out of that bag, it can be either blue or purple, so those 2 probabilities need to add up to 1, which is why if blue is 3/5, purple is going to be 2/5. So then after I pick my first ball, I put it back and I pick another one. So I have a second pick, which again can be either blue or purple. So we branch off again like this. Now, what these branches represent, if I follow down this path, if I start and my first ball is blue and my second ball is blue, I end up here. So this is the outcome that represents picking a blue followed by another blue. This outcome represents picking a blue followed by purple. This is purple and then blue, and this is purple then purple. We haven't finished filling it in yet because we haven't got the probabilities on these branches. So if my first ball was blue, and I then put that ball back and pick another one, what's the probability that this one is blue? Well, because the bag looks exactly the same now as it did at the beginning, there are still 3 blue balls in there out of 5, so it's still 3/5. And for the same reason, the probability that I pick purple is still 2/5. Same again down here, still 3/5 and still 2/5. So that's our probability tree filled in, but you usually use a probability tree to work out the probability that you pick, for example, blue followed by blue, which would be this outcome here. And the rule is, if you want to know the outcome of blue and then blue, you multiply the probabilities of each one of them happening. So the probability of getting blue followed by blue is 3/5 multiplied by 3/5. And to multiply fractions together, we just times the tops and times the bottoms, so it's 9/25. The probability that I pick blue followed by purple would be those 2 probabilities multiplied, which is 3/5 times 2/5, which is 6/25. Same again with purple followed by blue would be 2/5 times 3/5, which equals 6/25 again. And finally, purple followed by purple is 2/5 times 2/5, which is 4/25. So if I asked you a question like, I have a bag set out like that one with 3 blue balls and 2 purple balls, what's the probability that I pick a blue ball, put it back, and then pick another blue ball? And the answer would be 9/25. In this example that we just did, the second set of probabilities did not depend on the first. But what I'm going to do now is rub out some of this stuff and talk through a very, very similar example, but that has an important difference. So the example we're going to look at next is where the second probability does depend on the first one. In other words, what happens if I do not put the first ball back in the bag? So the probabilities to start with are going to stay the same. The probability that I pick a blue is 3/5, there are 3 out of 5. But then the probability that I pick another blue is no longer 3/5, because remember now, I don't put the ball back in the bag. And what that means is that after I picked the first ball and it was blue, well now my bag looks like this. So I've got 2 blue balls left in there. So the probability that I pick blue this time is 2 out of 4. Because there are now 2 balls there that are blue out of 4 balls altogether. And that means the probability that I pick purple is also 2 out of 4. Because there are 2 purple out of 4 balls altogether. Now, what if the first ball I picked was purple? Well, in that case, my bag currently looks like this. I've got my bag. Now, the first one I picked was purple, which means I still have 3 blue in there, but I've only got 1 purple left. which means the probability that I pick blue is now 3 out of 4, and the probability that I pick purple is 1 out of 4. I can then do the same kind of things as I did before. I can work out the probability that I get a purple followed by a purple, which would be 2/5 times 1/4, which would be 2/20. So that side of things is still the same, but sometimes your probability tree question will be such that the second set of probabilities doesn't matter. They're the same as the first. Or, like this example, the second set of probabilities can change depending on what happened in your first pick of the ball. One final thing to say, and then I'll put up a question, is that any of this stuff we have done is exactly the same if it was decimals instead of fractions. So if I'd have told you that this probability for blue was 0.6 and this probability for blue was 0.5, you'd still work out the probability of one thing happening after the other by multiplying them together. Right, that was a lot to digest. So there is a question there if you would like to give it a try. You might be able to do the first part and not the second part, that would be fine. Or if you feel like it just needs a bit more practice, it's fine if you want to just leave the video playing as I talk through the answer. So the first thing we're asked to do is complete the probability tree. And like we said earlier, each pair of branches has to add up to 1 because they're listing the possible outcomes. And as we know, all possible outcomes have to add up to 1. So the probability that I hit is 0.4, which means the probability I miss is 0.6. And we then see that the probabilities do change for the second set of branches. So the probability that I hit is 0.5, so a miss is also 0.5, because that's what's missing to add up to 1. And the same down here, the probability that I miss is 0.3, so the probability I hit has to be 0.7. That's the probability tree filled in. We then have to use the probability tree to work out the probability that I hit twice. And hitting twice means we're following this branch here. And like we discussed earlier, we multiply those two probabilities together to get the probability that one happens after the other. So 0.4 multiplied by 0.5, well 0.5 is a half, and a half of 0.4 is 0.2. So the probability that I hit twice is 0.2. And that's probability trees. You may want a bit more practice, you may want to watch again, that's absolutely fine. Key things to remember, the branches have to add up to 1. Whether it's a fraction or a decimal, they have to add up to 1. To work out the probability that one thing happens and then another one, you multiply the probabilities together. And you can have questions where the probabilities in the first set of branches are the same as the second, or in the examples that are currently on the screen, they can be different. So just watch out for that. And that's probability trees. Hope that helps.